In exercise 501, we're going to look at scatter plots. Now, obviously they are a visual demonstration, an example of a visual way to demonstrate data that has been collected, and in this case it's collected from about two variables. Normally our graphs, for example, you might be collecting information about the number of computers. That's one piece of data, and then you record how many people have one computer or two computers or three computers or whatever in their home. But you're really only collecting data about one variable. That's not the case with scatterplots. You're going to collect data about two different variables. And for that reason, our data is referred to as bivariate. Bi just meaning two variables. So data about two variables. Commonly, this data is collected about the human body. And for example, you can see here arm length and leg length. And because it refers to the body, it's often referred to as biometric data. So biometric data, specifically data about aspects of the body. Now, what we're looking, just explaining then a little bit more about the scatter plot. One dot represents two pieces of information. So that one dot telling me about a particular leg length, and I haven't put a scale on there, but that could be 95 centimetres or 90 centimetres long, and arm length, and that might be maybe 70 centimetres long. So we collect the data from one person, one dot for the two pieces of data. If after plotting our complete set of data, we seem to have a pattern occurring, then we're able to describe the relationship. We say there is a type of relationship existing between these two variables. You can see here I've jumped to a PowerPoint that I'm also providing you with. When you plot your results, you don't always get a relationship. So here's an example where there is no relationship. There's no pattern showing here. There's nothing like a straight line. So we would say there was no relationship between whatever these two things are here that were measured. And you might be wondering why we don't join these dots like we usually do, and the reason is because they represent two pieces of information, so we generally don't join them together. So I'm back to the Word document, and you have to be able to describe the type of relationship. So describe the type. Now, the features of a relationship include, if one exists, the direction and the shape and the strength. So, when you come across a question that asks you to describe the type, then you're going to be using words like positive or negative. So you would say the relationship in this case is in a positive direction. Remember, we talked about a line like that having a positive slope. So we'd say positive relationship. You will also describe the shape as linear, clustering, non-linear or outliers. I'll go back to the PowerPoint in a moment and show you the difference there so that you can complete this set of notes. And also the strength. So your relationship, there may be none, and you saw an example of that. It may be weak, moderate, strong, or perfect. So here in the PowerPoint, you can see that this example of a dot plot actually shows clustering. I think that's pretty obvious. So there's a cluster of results in this area and another cluster up there. So if you found you were presented with that, or you plotted points and they looked like that, you could say there was clustering. It's a way to describe what's happening. This one actually demonstrates outliers. So these are clearly the outliers. This data shows a linear pattern. Why linear? Linear means a straight line. The example back in your Word document notes also showed a linear relationship. It's positive because if we drew a line through here, it has a gradient that it would be positive. As one variable increases, so does the other. You might be able to think of examples about the human body where that happens. For example, as someone gets taller, so their height may be have a relationship to their arm length as they get older. Here's an example of a linear pattern which is negative, that as one variable is increasing, the other variable is decreasing. So we might be plotting here age against hearing ability in people, because we know as you get older, your hearing diminishes. We would describe this pattern as a weak positive linear pattern. Because while we can see that, something's going on, it does seem in general that as one increases, so does the other variable that you're measuring. It's not great. This one's a little bit better, so we'd say it's moderate. And you can see that's lining up a bit closer to a straight line. And this one is perfect. I think that's pretty obvious. So here you're given information about height of people. So somebody 190 centimetres tall had an arm span of 192. Somebody that was a little bit shorter, 187, had arm span 188. Notice that these are not in order. This is a little bit unusual. We haven't come across that sort of table before. Your data in your table won't necessarily be in order, so just be aware of that. In this example, you're asked to plot the data on a scatter plot. Let's have a look at what that looks like, and there it is. Please note you don't need to start both axes at 0. So these, you can see the axes here are not at 0, starting at 186. Again, that's an unusual feature of a dot plot as well. You're asked to describe the pattern. So it's and they've given you some guidance. They've said, is it positive, is it negative, is it 0, etc. So we would definitely say it was a positive relationship. Is it strong, moderate, or weak? It's definitely moderate. It's moderate. Comment on the statement: for a male swimmer, arm span and height are approximately the same. So these were of male swimmers, and how are we going? 194, 192, 194, 196, 193, yeah. I guess they're fairly similar. There's 188 and 189. I think you could say this shows that statement is true. Now for you to complete the notes, you might want to have another look at that PowerPoint. So I'm just showing you where those PowerPoints are, how you'll find them. So we're on the tab Student Notes. However, I'm not up on the Student Notes. I'm actually accessing the page underneath it here. At 501, you'll see that PowerPoint I just played. When I do the video for 502, you'll see a PowerPoint for 502 here. So if you want to go back and play those PowerPoints again, and you might need to, especially as the notes are no longer in colour, for you to pick up any differences in graphs where there's more than one thing happening on a graph, and normally it would be coloured. You'll pick up the differences by replaying the PowerPoint because it's in colour. But I guess so too are your notes. You should be right to get started with the questions from the UDO. Don't forget, please complete the notes. So you'll be drawing in some little graphs with a few dots indicating direction, shape and strength.